dear magnificence, Prorector and Dean of the University, Technical University of Cluj-Napoca, dear professor, colleagues, dear young colleagues, PhD students, and I can see that there are students as well here, ladies and gentlemen. I was very happy to come here and to give this presentation, and many thanks for the invitation. And I take the possibility to congratulate already now for the excellent organization already of the conference, considering the program and proceedings and the invitations, the large scale of the conference. I also congratulate to select the place of the symposium. This is an excellent place. Everybody is together, and some colleagues can join during the day, which is a busy day probably, and tomorrow for them from the university. I split my presentation into 3 parts. Some words about PhD studies in general, and some words about FIP. I'm representing the International Federation of Structural Concrete as well in this period, and some words about our duties and possibilities in research in a short form. So first of all, there is the general question, what does that PhD studies, PhD work mean? And this is always, all over the world, the highest level of university education. It was in previous time as well, and even today when we have BSc, MSc, and PhD studies. It is very, very important for the PhD candidates themselves, for their future activities and for their future possibilities. But this is very important also for the universities, because some of these young colleagues may become professors in the future. This is definitely the case, and they are also important for the industry, on the other hand, because we need good and highly educated people in the industry as well. PhD programs are rather different in different universities, and the system of PhD studies, surprisingly, rather different. But the purpose of these PhD studies is always the same, to have high-level research and high-level results, which is very, very important. I consider the 3 main, most important objectives of a PhD symposium like today, to provide a forum for PhD students to present their work, which is already done, and which will be, and to consider the future possibilities, to discuss their results. This is very, very important because they need to discuss it with their supervisors, but also internationally, and to establish contacts for themselves among them and with other professors in the world to continue their research. It was already mentioned, and we discussed it even yesterday. So when I became responsible at my faculty for all the PhD studies in '96, I started with a new idea and developed the International Symposium for PhD studies in civil engineering. And it goes around the world now. So I organized it in '96 and '98, and then it was organized in Vienna, Munich, Zurich, Stuttgart, and last time Copenhagen and Karlsruhe. You can join next time as well. You can come for the next symposium like this one here, but also you can join to this series. It comes next time to Canada in 2014, then to Tokyo, and then to Prague. FIB, International Federation for Structural Concrete. Some of you are already working in this association. Romania is member of this international association, one of the most important members. FIB is represented in all the continents. We have 41 countries from all over the world. We have 2 new countries starting this year, South Korea and South Africa, and we are in discussion with several other possible new countries as members. We, of course, organized symposia and congresses this year in Stockholm, June, next year in Tel Aviv, a symposium, and our congress in 2014 is in Mumbai. You can send your contribution still there. We have a very important journal called Structural Concrete. It has an impact factor, so it can be very valuable for your research and PhD evaluation if you go to the committee. So we are happy to receive your manuscript, and we are happy if you read this journal. Not everybody knows that we have even this is the only international association which has even a textbook. This was a joint product of 18 professors and some colleagues from the practice, and this can be used in advanced studies, and it has already 5 volumes. We call it as Structural Concrete. This is mainly for concrete, textbook on behavior, design, and performance. Most important product of this association is the model code. Some of you already know it, that we have model code 78, 90, and we just voted on model code 2010. It is already printed as bulletins, 2 bulletins. You can see in the top right, and it will be printed during next year as a hardcover book as well. And this, we think that this will be very, very important for the code development in the next 10 years, especially for Eurocode 2 as well. We contacted already the responsibles, and they are happy that we produced it. And there were also 2 other model codes. Model codes must be voted in the General Assembly on seismic design of concrete structures, and also model code for service life design. Our research should be directed finally to produce beautiful structures and suitable structures to help our life in any respect. These are just a couple of examples. This is one of the fiber-reinforced concrete shells. This is actually a replica. The original one was constructed, as you know, in Mexico, and this one you can see here in Europe, in Valencia. Another type of example, bridges, beautiful bridges from the 30s, as you very well know, but also very recently from Prague. This is just one example for myself for the optimal use of the material and the form itself in this shell in Torino. This is a large hall. This is the end part of this hall, as you know. This is the exhibition hall there. And I took one of the tricky constructions. So here you need really a good analysis to find this tricky form, which was awarded also by FIB, to give a special shape and special form of a structure to shock a little bit the people who can see that. I took also an example of steel structure, very nice light steel structure, actually in Canada, so there was no buckling under snow load and so on. Very nice, very elegant steel structure. If we start to use new materials, we should consider the differences in behavior. This is a high-strength concrete, and you should not forget about the brittleness, lower ductility of high-strength concrete, but still we have to try to use them and to consider to use the advantages of these materials. We use more and more fibers, steel fibers, polymeric fibers, glass fibers. We should not forget about, on the other hand, we are happy with the advantages, but there are some considerations, especially for glass fibers, which are not solved, that not all of them are alkali resistant in concrete, and of course not even those one really alkali resistant when the supplier declares to be alkali resistant. So it should be considered carefully. We can go into very high percentages of fiber applications, and in this case we get a completely different material. Even the tensile strength increases, compressing strength, and then the incredible increase of ductility and toughness. We have now completely new material. It started already 15 years ago at least. These are 5 millimeter pre-stressing wires. The bottom one is very well known steel wire, and most of you have seen already used carbon fiber polymer wire. Of course, this is a different material, and there are lots of advantages. For example, the corrosion of these CFRP viruses, the electrolytic corrosion is completely excluded. But on the other hand, we have to deal with these materials carefully, and these are always part of PhD studies. We have lots of modeling. This is just one type of modeling. You have completely different types of modeling with violent elements and so on. I just wanted to use the word of modeling and to emphasize, I'm sure that some of the presentations will speak about modeling, a rather large part of the presentations today and tomorrow. And I wanted to pick up one very important aspect before coming to the conclusion on the next page. This is earthquake. This is the real displacement, relative displacement after the Kobe earthquake. You can see here, this was about 1 meter. So this is, you know it very well, most of you are expert in this field, 1 meter in the longitudinal direction and the vertical direction, half a meter. So this produces incredible loads, incredible deformations in our structures, and you can see this was the flyover. This part is in a museum now. You can visit all this, what you can see here, next to Kobe on one of the islands where the fort was really landing. So this is plastic hinge, some of the real plastic hinge. Some of the young colleagues will speak about plastic hinges today or tomorrow. So coming to my conclusions and summary, so don't worry, I tell it to our young colleagues, you have lots of possibilities for research. There are lots of new materials, lots of new developments in material field. You can see new types of cement compositions and lightweight aggregates and fibers and anything else. And behavior, I would like to call again the attention. We have to be sure about the behavior of these new types of material, and we are happy to construct nice, beautiful, elegant new structures. Thank you for your attention. I wish you a successful PhD symposium and successful PhD defense for the young colleagues. Thank you very much.